Now let us see the second question. Factorize the following. Here we have 9 sub questions. Let us see the first one. 6x square minus 9x minus 10. So we have to take the product of 6 and minus 10. This is minus 60. Now we have to find a pair of factors of minus 60 whose sum is minus 9. M into n should be minus 60. M plus n should be minus 9. Let us find first factors of 60. 1 into 60, 2 into 30. 60 is also divisible by 3, so 3 into 20. It is also divisible by 4. When we divide by 4, we get 15. So 4 into 15, 5 into 12, 6 into 10. 60 is not divisible by 7. 60 is not divisible by 8. 60 is not divisible by 9. Then 60 is divisible by 10. Here we have obtained all the possible pair of factors which give product as 60. We want a product minus 60. So we have to take one factor as negative. We want sum of those factors as minus 9. So we can take difference of these factors here. Minus 1 into 60 we can take. Where do we get minus 9? Say minus 3 plus 20, we get 17. The difference is 17. Here the difference is 11. Here the difference is 7. Here minus 4 plus 15 is 11. Here minus 5 plus 15 is 7. Here minus 6 plus 10 is 4. So we are unable to obtain suitable factors satisfying these two conditions. Let us go for algebraic method. Mn is equal to minus 60. M plus n is equal to minus 9. To find m and n, first we have to find m minus n. So m minus n whole square is equal to m plus n whole square minus 4mn. This becomes minus 9 whole square minus 4 into minus 60. So we get 81 plus this is 240. So we obtain 1 here, 2, then 3. 321. M minus n is equal to plus or minus root of 321. Now let us find square root of 321. Let us use a prime factorization method. 321. This is divisible by 3. This is not divisible by 2. And next prime number, if we take 3, it is divisible by 3. When we divide by 3, we get 1. Then this is 21. So 0, 7. 107. 107 is not divisible by 5. It is not divisible by 7. It is not divisible by 11. It is also not divisible by 13. So 107 is a prime number. So m minus n is square root of 321 only. Now if we take m plus n is equal to minus 9, and let us take m minus n as positive square root of 321. Now to find m, let us eliminate n. This can be done by adding these two equations. Adding, we get 2m is equal to minus 9 plus square root of 321. Then m is equal to minus 9 by 2 plus square root of 321 by 2. Substituting m in first equation, let us take n. So n is equal to minus 9 plus 9 by 2 minus square root of 321 by 2. This becomes minus 9 by 2 minus square root of 321 by 2. Now here we have obtained m and n values. The given quadratic polynomial is 6x square minus 9x minus 10. 6x square minus 9x minus 10. This we have to write as 6x square plus minus 9 by 2 plus root 321 by 2 into x plus minus 9 by 2 minus root 321 by 2 x minus 10. Here we have x as a common factor. We remain with 6x here plus minus 9 by 2 plus under root 321 by 2. Now we can take minus 9 by 12 minus 321 by 12 as a common factor. We remain with 6x plus minus 9 by 2 plus under root 321 by 2 as common factor. So now this can be written as 6x plus minus 9 by 2 plus under root 321 by 2. When we take this one as common, we remain with x here plus minus 9 by 12 minus under root 321 by 12. 8 into 15. 8 into 15 is 120. Now we have to find a pair of factors of 120 whose product is 120 and whose sum is minus 26. Mn should be 120 and m plus n should be minus 26. First, let us find positive factors of 120. We can consider them as negative factors so that their sum is negative 26. So 120 can be written as 120 into 1 into 120, 2 into 60, 3 into 40, 4 into 30, 5 into 24, 6 into 20, then 8 into 15. It is not divisible by 9. It is divisible by 10. So 10 into 12. 120 is not divisible by 11. Then it is divisible by 12. 12 is already covered. These are all the possible pairs of factors whose product is 120. Now we can take negative signs to these also. Let us just add modulus and find out whether it is equal to 26. Here we find this one 6 and 20. When we add these two factors, we get 26. So the required factors are minus 6, minus 20. So this can be written as 8x square minus 20x minus 6x plus 15 as it is. These two can be grouped and these two can be grouped. Here we get the HCF as 4x. So 4x is taken as common factor. We remain with 2x here and minus 5 here. Now we have to get plus 2x here. So we take minus 3 as common factor. Then we remain with 2x here and here we remain with minus 5. This becomes 2x minus 5 taken as a common factor into 4x minus 3. Here 12 into minus 6, it is minus 72. We have to get the sum of the factors as minus 14. The product is minus 72. So the factors, out of the factors, one is positive and the other is negative. M into n is equal to minus 72. M plus n is equal to minus 14. We can find the factors of 72 first, and we can take the difference of the modulus. That should be 14. 1 into 72. 72 can be written as 1 into 72. It is divisible by 2. When we divide by 2, we get 36. 2 into 36. Here also the difference is not 14. 3 into 2, 4. 3 into 24. Here the difference is not 14. Then 4. When divided by 4, we get 1, 8. 4 into 18. Here the difference is 14. So 4, 18. We want minus 14. So 4 minus 18. This is the right choice of pair of factors. 4 into minus 18. So this can be written as 12x square minus 18x plus 4x minus 6. Here we can take 6x. 6x. 6x is the HCF. So 6x is taken as common factor. We remain with 2x minus 3. Here we want a positive 2x. So we can take 2 as a common factor. So we remain with 2x and here minus 3. Taking 2x minus 3 as a common factor from these two units, we get 2x minus 3 into 6x plus 2. 6x plus 2 can be written as 2 into 3x plus 1 when we take 2 as common factor. So 2x minus 3 into 2 into 3x plus 1. So we can rewrite it as 2 into 2x minus 3 into 3x plus 1. We can factorize this one taking the common factor 2 initially itself. 2 into minus 5. It is minus 10. We have to find two factors m and n whose product is minus 10 and whose sum is minus 9. Minus 10 can be written as minus 1 into 10 or 1 into minus 10. Minus 2 into 5 or 2 into minus 5. These are the only possible pair of factors. We want to get the sum as minus 9. So here 1 and minus 10. Sum of 1 and minus 10 is minus 9. 1 plus minus 10 is minus 9. So 1 and minus 10. This is the right pair of choice of factors. So this can be written as 2x square minus 10x plus x minus 5. Now taking 2x as a common factor, we remain with x here and minus 5 here. Here again we have x minus 5. We can take 1 as a common factor. So 1 into x minus 5. Here taking x minus 5 as a common factor from these two units, we get x minus 5 into 2x plus 1. Here we have 15 and 2. So 15 into 2 is 30. We have to find the factors of 30 whose sum is 7. We have to find the pair of factors of 30 whose product is 30 and whose sum is 7. M into n is 30. M plus n is equal to 7. So then what are the factors of 30? 1 into 30. 30 can be written as 1 into 30, 2 into 15, 3 into 10. Then 30 is not divisible by 4. Then 5 into 6. After that 6. 6 is already covered. So these are the only possible ways. Then what is the sum here? 1 plus 30 is 31. Here 2 plus 15 is 17. Here 3 plus 10 is 13. Here 5 plus 6 is 11. So we have not obtained 7. Let us solve this algebraically. M into n is 30. M plus n is 7. To find m and n, first we have to find m minus n. M minus n whole square is equal to m plus n whole square minus 4 into mn. This becomes 7 square minus 4 into 30. This is 49 minus 120. 49 minus 120 is minus 71. So m minus n is plus or minus under root 71. So we are not going to obtain real terms in the linear polynomial factors. Here we can take 5 as a common factor. So 5 into 6x square plus 13x plus 6. Now we factorize this one. So 6 into 6 is 36. So we have to find factors of 36 whose sum is 13. M plus n should be 13. 36 can be written as 1 into 36, 2 into 18, 3 into 12, 4 into 9, then 6 into 6. So we want the sum of the pair of factors should be 13. This 4 plus 9 is 13. So 4 and 9 is the right choice. So this can be written as 5 into 6x square plus 4x plus 9x plus 6. So 5 into, here from 6 and 6x square and 4x, we can take 2x as the common factor. We remain with 3x plus 2. Then here also we should obtain 3x plus 2. Here we have to obtain 3x. So taking 3 as a common factor, we remain with 3x here and 2 here. This can be written as 5 into, taking 3x plus 2 as common, we rewrite it as 3x plus 2 into 2x plus 3. We can write it as 5 into 3x plus 2 into 2x plus 3. 6 into 8, it is 48. AC is 48. Now we have to find pair of factors of 48 whose sum is 19. M plus n is equal to 19. What are the factors of 48? 1 into 48, it is divisible by 2, so 2 into 24. 48 is divisible by 3, 3 into 16. So immediately we can observe that 3 plus 16 is 19. So 3 and 16, this is the right pair of choice. So this can be written as 6x square plus 3x plus 16x plus 8. Taking 3x as common factor, we get 3x into 2x plus 1. Here first we have to get 2x and the HCF is also 8. So taking 8 as a common factor, we remain with 2x plus 1. Now taking 2x plus 1 as common factor, the remaining factor is 3x plus 8. Here we have 3 into minus 8. It is minus 24. Now we have to find the factors of 24. One of the factors should be negative. We want the sum as 2. So we have to take the difference of the absolute values. M into n is equal to 24. M plus n should be equal to 2. Now let me find factors of 24. 1 into 24, difference is not 2. So 2 into 12, the difference is 10. 3 into 8, the difference is 5. Then 4 into 6, here the difference is 6. When we take minus 4 and plus 6, the sum is 2. So minus 4 plus 6. This is the right pair of choice. Now this can be written as, we can take x square. Instead of x square, we have x power 4 here. We can write it as plus 2 power y minus 8, where y is equal to x square. Now this is a quadratic polynomial. Let us proceed. 3y square minus 4y plus 6y minus 8. Taking y as a common factor, we get y into 3y minus 4. Here taking 2 as a common factor, because we have to get 3y here. Instead of taking minus 2, we have to take plus 2 as a common factor. 3y minus 4. Here 3y minus 4 into y plus 2. This is equal to 3x square minus 4 into x square plus 2. So here also we have x power 4 and x square terms. Taking y is equal to x square, we can rewrite it as xy square minus 6y square minus 23y plus 20. Now it is a quadratic polynomial in variable y. So now let us take AC. AC is equal to 6 into 20. This is 120. So we have to choose two pair of factors whose product is 120 and whose sum is minus 23. So both m and n are negative here. First let us take absolute values only. 120 can be written as 1 into 120, 2 into 60, 3 into 40, 4 into 30, 5 into 24, 6 into 20, 8, 8 into 15. So here we obtained the sum as 23. So we can take minus 8 into minus 15. So minus 8 plus minus 15. This is minus 23. So right choice is minus 8 minus 15. So this can be written as 6y square minus 8y minus 15y plus 20. This is equal to, we can take 2y as a common factor. 2y into 3y minus 4. Now when we take, we can take minus 5. We have to get 3y here. So we will take minus 5 as a common factor. We remain with 3y minus 4. Now writing as 3y minus 4 as a common factor, we get 3y minus 4 into 2y from here and minus 5 from here. 2y minus 5. Now substitute y value, 3x square minus 4 into 2x square minus 5. See you in next video.